All right, for homework 920, I'm just going to have you copy the work we're about to show you here. You don't have to write down all these words, but try to show as much work as possible. All right, for these matching ones, again, I wanted to review with you the fact that these will match these patterns. If I'm looking at this first one here, this is saying that I'm starting with 3, and then I'm timesing by 2 each time. So 3 times 2, 6, 6 times 2, 12. So that looks like that is this one right here. If I look at this next one here, a little trickier. This is saying it's going up by 4 each time, going up by 4. It's saying if I backtrack 1, I'll find the 0 term. That is going to match this data set right here. And again, I can see that by seeing that this is going up by 4, going up by 4. It's the only one of all of these that is going up by 4 that has 4 in the right spot in front of X. Or you could approach it like this. This was the first term. When I plug in 1 for X, 4 times 1 minus 3 gives me 4 minus 3 gives me 1. If I plug in 2 for X for the second term, I get 4 times 3, 8. 8 minus 3 gives me 5. If I plug in 3 for this third time into this equation right here, I'll get 4 times 3, 12. 12 minus 3 is 9. That's another way to try to look at it. Or, like I said, adding that 4, it's the only one that has the 4 in the right place. The other ones have nothing to do with 4s. This 4 is subtracting, so not even close. All right, next one down. If I look at it, this one right here is the only one that has any kind of fraction in it. And of course, those fractions, as you keep times in them, they just keep expanding, but the top number stays the same. Remember, that bottom number increases, but that top number stays the same. So obviously the only one with any kind of fractions, this one right here. And then the last one, this is saying that you're starting off with 3. First term is 3, and then this is saying minus 4 every time. So 3 minus 4, negative 1. Negative 1 minus 4, negative 5. Negative 5 minus 4, negative 9. So you can see that one matches this data set right here. So what I'd like you to do is try to write those down and then show the work for this. All right, this one says for a sequence, first term is 9, and this is decreasing by, let's say, 11%. So that means it's going down by 11%. I need to subtract that from the total 1. So I change that 11% to a decimal, take that decimal, move it twice to the left, becomes 0.11. If I subtract those two numbers, that will be my R number. So if I take 1 minus 0.11, it gives me the R number is 0.89. So to write this recursive, I'm going to use the letter M. I'm going to say the first term is 9, because that's what they tell me. And then I'm going to use this equation, recursive form. M of t equals M of t minus 1 times, super important, that 0.89 term. That will reduce your numbers down by about 7 or 11% each time. And what I'd like you to do is show me that. So knowing that the first term is 9, and if I keep timesing by 0.89 each time, it's going to whittle it down a small percent. So 9 times 0.89 is 8.01, going down a little bit. 8.01 times 0.89 gives me 7.1289 rounded. Looks like 7.13. If I take that 7.13 times 0.89, that gives me 6.13. 0.3457. Remember, rounding to here. If I get my pen to right, rounding to this number right here, you're looking at this number to indicate to round that number up or not. 5 or more, that 4 goes up by 1. 4 or less, I would leave that alone. So that rounds up to 6.35. And you can see those numbers are going down slowly. If I was to graph that, it would start up here at 1.9, and then it's going down. The trick though, for those my high achievers, this is the first term. If I wanted to find that 0 term and go backwards, I'm timesing not by 0.89, but timesing by the reciprocal of 8.9 going to the left. Because if you're timesing by 0.89 to the right, you're dividing by 0.89 going to the left. Or you are dividing by 0.89, which is the same as multiplying by the reciprocal, 1 over 0.89. So if I take that 9 and times by 1 over 0.89, or if I take that 9 and divide by 0.89, it will give me the 0 term, which you can see is a little bit higher, 10.11. All right, first word is reciprocal. Reciprocal. All right, last one, last problem. This one is increasing. We're saying he's making, let's say, $45,000 a year. This one increasing, so we'll say 6% increase every year. He will have made in 1 year 45,000. That is the first term. Second word, of course, is blue. Blue. So for this one, at the first year, the first term, 45,000. This one, since I am going down, going up, I take 1 and I add 6%, change to a decimal. Remember, take that decimal twice to the left, gives you 0.06. So if I add that, this is going up by 0.06. That is my R number. This one wants you to use the explicit form, which of course, the explicit form I could get from using the first term times whatever R number to the x minus 1. If I plug those in, that will complete this. This is my M1. This is my R. So if I write that equation, it is M of t equals that 45,000 times 1.06 to the x minus 1 power. That's the answer I'm looking for. If I want you to use it, like today, first term, 45,000. If I times that 45,000 times 1.06, it starts to go up a little bit. 47700. If I times that by 1.06, goes up a little bit higher. 50,562. If I times that by 1.06, gives me even higher. 53,595.72. All right, last word is jury. Jury. Good luck. Hopefully this helped you.